Reducing and non-reducing sugars. In this module, you will learn how to classify carbohydrates as reducing and non-reducing sugars. Let us begin our study by considering the reaction of common carbohydrates with an oxidizing agent like the Fehling solution, which is a blue liquid. Let us first consider glucose. On mixing an aqueous solution of glucose with Fehling solution and then warming the mixture for some time, the blue color of Fehling solution changes to red. If the same reaction is carried out between an aqueous solution of fructose and Fehling solution, the same result is obtained. Even in the case of an aqueous solution of maltose and that of lactose, the result for this reaction is the same. All such carbohydrates that react with Fehling solution and change their color from blue to red are reducing sugars. On the other hand, when the same reaction is carried out with an aqueous solution of sucrose, the color of Fehling solution does not change. Such a carbohydrate that does not react with an oxidizing agent like Fehling solution is a non-reducing sugar. Let us now see what makes a carbohydrate reducing or non-reducing. Glucose is a monosaccharide that has a cyclic structure with a free hemiacetyl group. In the solution phase, the ring structure of glucose opens up at the carbon bearing the hemiacetyl group. During the ring opening, the hemiacetyl group changes to a free aldehyde group. Now you may know that a compound that bears a free aldehyde group can be readily oxidized by Fehling solution. Thus, glucose is readily oxidized by Fehling solution and is a reducing sugar. So, all carbohydrates that are identified as reducing sugars bear a free aldehyde group in their solution phase. Fructose is also an example of such a carbohydrate. It is a monosaccharide with a hemiketyl group in its cyclic structure. In the solution of fructose, the ring structure opens up and the hemiketyl group changes to a ketonic group. Interestingly, under the conditions of reaction with Fehling solution, the open chain structure of fructose isomerizes to the open chain structure of glucose. This way, fructose has a free aldehyde group in its solution phase and is a reducing sugar. Another example is maltose, which is a disaccharide. Maltose has two glucose units joined together by a glycosidic bond. The hemiacetyl group of one of these glucose units takes part in the glycosidic bond formation, whereas the hemiacetyl group of the other glucose unit remains free. In the solution of maltose, the ring of the glucose unit with a free hemiacetyl group opens up and the free hemiacetyl group changes to a free aldehyde group. The free aldehyde group enables maltose to be oxidized by Fehling solution, thus making it a reducing sugar. Similar to maltose, lactose is also a disaccharide with one galactose unit and one glucose unit joined together by a glycosidic bond. Both galactose and glucose has one hemiacetyl group. However, the hemiacetyl group of the galactose unit takes part in the glycosidic bond formation, whereas the hemiacetyl group of the glucose unit remains free. The ring of the glucose unit of lactose opens up in the solution phase and its free hemiacetyl group changes to a free aldehyde group. The free aldehyde group enables lactose to get oxidized by Fehling solution, thus making it a reducing sugar. In contrast to reducing sugars, non-reducing sugars do not bear a free aldehyde group in their solution phase. An example is sucrose, which is a disaccharide with one glucose unit and one fructose unit joined together through a glycosidic bond. The glucose unit has one hemiacetyl group, whereas the fructose unit has one hemiketyl group. Both the hemiacetyl and the hemiketyl groups take part in the formation of the glycosidic bond of sucrose. This way, there is no free hemiacetyl or hemiketyl group in the cyclic structure of sucrose. Thus, in the solution phase, the cyclic structure of glucose does not open and there is no free aldehydic group. And that is why sucrose is a non-reducing sugar. Let's recap. The carbohydrates that are oxidized by the oxidizing agents like Fehling solution are reducing sugars. The carbohydrates that are not oxidized by the oxidizing agents like Fehling solution are non-reducing sugars. A reducing sugar bears a free aldehyde group in its solution phase. A non-reducing sugar does not bear a free aldehyde group in its solution phase.